Mercury forms alloys with most metals in a process known as amalgamation. Last week, I messed around and tested it out with some gold leaf, and it was pretty cool. This time though, I'm gonna see what happens when I add it to aluminum. It's supposed to be quite destructive, which is why you're not allowed bringing mercury on a plane. So I went to Home Depot and I bought a strip of aluminum. This little crater is important because mercury is super annoying, and without it, it would just slide off the plate. Under normal conditions, aluminum is surrounded by a protective oxide layer. Sometimes, it's possible to get things going by manually scratching away the oxide layer. I tried doing this about 2 or 3 times, but it wasn't working for me. I even tried to brute force things using a drill, but that didn't get things going either. I thought that maybe it was just super slow to get started, so I went to lunch and I left it for about an hour. When I came back, nothing had changed, so clearly I have to use a different strategy. Instead of trying to remove the oxide layer mechanically, I'm gonna try to do it chemically. So I took out all the mercury and I added some dilute hydrochloric acid. The hydrochloric acid quickly reacts with the oxide layer and dissolves it away. I let it go for about a minute and then I get rid of the acid. With the acid gone, we'll start to reform the oxide layer, so it's important to add the mercury quickly. The amalgamation started almost right away, but it's really hard to see. In the reflection, you can see me lean over to get a better look, and I noticed some very small hairs forming between the aluminum and the mercury. In real time, this process is really slow, so I set things up for a time lapse. So the major thing going on here is the combination of the mercury with the aluminum to form the amalgam. Some of the amalgam that forms gets dissolved in the mercury and makes its way to the top. When it gets there, it comes in contact with oxygen in the air and it reacts to form white aluminum oxide. This part of the process is pretty short-lived though, because it quickly gets covered and protected by the oxide. This prevents fibers from growing directly from the mercury, but obviously they continue going out from the sides. This happens because some of the mercury is dissolving into the aluminum. The amalgam here also reacts with air to form the oxide, but the difference is that it doesn't shut itself down. The dissolved mercury can continue to creep along the surface and amalgamate more aluminum. In theory, this process should keep going until the entire surface is covered with a thick layer of the oxide. The mercury could also penetrate deeper into the aluminum and compromise its strength, but I think that takes a really long time to do. About 4 hours later, I decided to end the time lapse. I spun the thing around, and when I noticed the other side looked a lot cooler, I was a little bit sad. Anyway, when I poke at it, you can see that it's not structurally very strong. I'm not sure what I was expecting, but I was surprised at how fragile it was. It looks like there's quite a bit of aluminum oxide here, but surprisingly, there's only about 200 milligrams.